this is problem 126 of Neetcode 150, merge triplets to form a target. So you're going to be given an array containing many lists of triplets. Triplets is going to be 3 numbers, and you're going to be also given a target, which is going to consist of 3 numbers. And we can read the problem together. So we're going to be given a 2D array of integers, triplets, where the triplets at a particular index is going to be another triplet. And okay, you're going to be given an array of integer targets, so nothing super interesting to add here. To obtain the target, you may apply the following operation to triplets. So what we can do is that we can pick more than one triplets to form the target, but in this case, we will basically have to take all 3 and take the maximum value at each index of each of these triplets. So if I take the triplets I and the triplets G, right, and I want to see if by combining them I can potentially arrive to my target, well, basically combining those or using those two um, will create another triplets where at each position you're just going to take the maximum value between uh, the value of both triplets at that position, right? So A at A I A G B I B I B G. So for example, here if I look at this example 1 inner triplets, we have first array of integers containing 1, 2, and 3, and then we have a second array of integers containing 7, 1, and 1. And basically, if I combine both to have a target of 7, 2, and 3, I will initially take the maximum value between 1 and 7. So it's going to be 7, which matches the first character here. And I will go for the second character. So what is 2 greater than 1? Yeah, so I'm going to put 2 inside my newly constructed triplet. And now I will go see the next value, and I have a 3, I have a 1, 3 is greater, so I'm going to add 3 in the new array that I'm constructing. And this new array is going to have to match the 7, the 2, and the 3. So notice something here, okay? If, for example, I had at any position inside any of these 2 triplets a value that is greater than the value in the target at that same position, then we will have a problem. So for example, let's say here instead of a 1, we had a 5, right? We know that this maximum value will be picked up and be added inside the new string that we constructed. So if at any position there's a value that is greater than the value of the same position inside our target, we cannot take this triplet. It's as simple as this. Also, there's a thing that they don't mention, but you are not forced to take 2 triplets. If there's a triplet that match exactly the target, you can use this value. If you feel like using 3 triplets, go ahead. You will definitely not need to use 4 triplets. That's just some basic math here. So yeah, you can use 1, 2, or 3. If we take a look at this example here, so we have a 2, we have a 1, we have a 5. These are our values. So if we don't think of an algorithm and just see like, can we actually build that? Well, to match the first value of the target, we will have to take a 5. So we can take this, we're going to have to take this last triplet here because we need a 5 to start our new string. So at this point, it doesn't really matter which one we pick, like whether we pick the 2, the 5, the 6, or the 1, 4, 4 as a second, or if we just decide to start with our last triplet and see if we can actually build the same target with only this triplet. But then we need a 4. But here comes a problem, because when we use this triplet, we are then forced to have this 7. And we can't pick a value that is less than 7. Because if we take, let's say, this other triplet, because it contains a 4 at the index 1, and this is the value we want to have at the index 1, well, the thing is that we are going to have to use the maximum value between this 7 and this 4, since we're using the triplet that contains the 5 that we need for the index 0. So that will not work. All right, so let's see how we can do this in a time complexity of big O of n. So just by going once through every single triplet. So what I will do is that I will create a set of basically I will create a set for all the values that we can make inside our triplets. So I will call this match a val. That will be a set. All right. And now I will have linear time complexities. So I will have to use a for loop and go through every single triplet. So for t in triplets, I think this makes sense. Now what we want to do is that we want to go see every single value inside each triplet, and if any of them is greater than the value of the target at that same position, then we're gonna have to continue, because we know that by using this particular triplet we will have something that is not the target itself, right? So we're gonna do this by saying if t at the index 0 or t at the index 1 or t um, at the index 2. Okay, so if any of these is greater than the target at that same index, well, we're not going to be able to use this. So what we will do is that we're just going to say continue. All right. And now I will go through every single value inside this particular triplet that I am in. And I will see if it matches the value of the target. So I'll use it enumerate. So I will say for IV. I is for the index of that particular value, and V is for the value itself. So for IV in enumerate T, okay, if the value, so if V is equal to basically the target value at the index I, okay, if this is true, to match val, I want to add this particular index. I'm adding this index because now we know that let's set our target is a 7, 2, and 3, and we are looking at the triplets 7, 1, and 1. We know that at the index 0, we can use the 7 from the second triplet, and we know that by using the second triplet, we will not get a value that is greater than any value inside our target because we pass this checked here. Okay, so now we know that the index 0 is set. If I take a look at this particular example, when we're going to go see the second and the third number, we're going to have 1 and 1, which are both smaller and not equal to the value of the index 1 and 2 of the target, meaning that these are not going to be good enough to actually create a triplet that is equal to the target. But we know that we can use the first entry to exactly match the index 0. So now inside our match file, we know that the index 0 can be completed. And then when we're going to pass the first triplet, we're going to pass first the index 1. And we're going to check if 1 is equal to 7. So the value in the target at this exact same index. And it is not going to be the same. But it is fine because there's another triplet that has a value that can match this 7. But then we're going to go see 2, and we'll see that 2 is actually matching the 2 at the index 1. So what we will do is that in match val, we will add the index 1 to say that we can actually complete the index 1 using our triplets. And same thing for the index 2. We have basically a triplet whose value are all smaller or equal to the values of the triplet at each of their position. And we can actually build up the index 2 with the value of the index 2 in the first triplet. So see, that's really like the entire algorithm. What we can return now is basically, we know that the length of match val should be equal to 3. So index 1, 0, 1, and 2 should be in there if we have basically a composition of triplets that can be used to compose our target. So we're going to test this out. We have an indentation error, so let's just solve this really quickly. So what is the indentation? Oh, okay. I think my if statement here is a little bit undisciplined. So let's test this again, and now this works. Awesome. So let's speak about the complexity here. So in terms of time complexity, I think I mentioned it earlier, but we're going once through every single triplets, and um, so we're gonna have a time complexity of big O of technically of three 3 raised to the 3 raised to the number of triplets times n, because for each triplets we're going to go through every single 3 triplets, but this is going to be a constant, so overall the time complexity is going to be big O of n. um, in terms of space complexity, we are we created a set which is going to contain at most 3 values, so it could go up to big O of 3. But since it is a constant, we are going to cut that down to big O of 1. So our time complexity is going to be big O of n, and our space complexity is going to be big O of 1. Not too bad at all. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.